that I'm going to go ahead and get started. I discovered that we have in our audience at least two people who haven't seen the show. Are most of you house watchers, or okay, the avid fans are here, I see. For those who haven't watched this show, Gregory House is a doctor who is a crack diagnostician. He does diagnostic medicine, and he has 3 doctors working with him, Dr. Chase, Dr. Cameron, and Dr. Foreman, as his assistants and the people who ask the questions that presumably we, the TV viewing audience, would ask so that he can explain and be brilliant. And he's really brilliant, and he's also impressed with his own brilliance, and he's not terribly nice. And he's also a drug addict. So this is the doctor that you want to call, definitely the guy. But in all of these shows, he comes up with something incredible at the end. The day is saved. Actually, there's a couple of episodes where the day is not saved, but mostly the day is saved. And in the course of getting there, there are many detours through various diseases that mostly aren't that common, I don't think. And you've probably seen on medical shows before where they say something like, when you see X, think horses, not zebras. They would tell that to medical students. Well, it's all zebras all the time, it seems like, on House. So anyway, it's a great show. It's very entertaining. It's on its 4th season, which starts next Tuesday night. So we're going to just look at shows from the first 3 seasons. And this is a very common thing that we do in Science Study Break. We look at TV shows, we look at movies, and we bring in somebody who feels like they're just itching to talk about them. We've had people come and talk about the TV show 24, when they had the bioterrorism season. We had someone come and talk about phylogenetic analysis and crime solving using an episode of CSI. We've had people talk about climate change in movies like The Day After Tomorrow. Or we've had people talk about drugs and A Scanner Darkly. So we're always looking for suggestions. At the end of the show, you'll notice that there's a form in your chair. Please fill it out. If there's a show that you'd like to see us tackle, or a movie that you'd like to see us tackle, let us know. I will say that if you want to see us tackle Lost, tell me how to do it, okay? tell me what it is that's the topic that could be addressed, because there's a lot of calls for Lost, but I don't quite know what the scientific end would be there. My impression is it's kind of paranormal or something. So let me know. If you want Lost, then you get to be an assistant producer. Okay, my name's Roxanne Bogutska, and I'm a science instruction librarian here at the Life Science Library. And today, to help us with House, we have Dr. Leanne Field, who is a distinguished senior lecturer in the School of Biological Sciences here, and an adjunct associate professor at the UT School of Public Health. Dr. Field began her career at the Centers for Disease Control as a microbiologist in 1972, and has had an ongoing professional interest in infectious disease and public health ever since that time. She joined the faculty here at UT Austin in 1997 and enthusiastically teaches courses to undergraduate students in medical microbiology, human infectious diseases, and emerging and re-emerging infectious diseases. She also directs the public health internship program here, which gives undergraduate and post-baccalaureate students the opportunity to explore careers in public health by conducting research projects in epidemiology or laboratory science at the Texas Department of State Health Services and the Austin Travis County Health and Human Services Department. She's very busy. She's also the director of the Clinical Laboratory Science program at the university and the faculty director of 2 undergraduate students' organizations, the Society of Public Health Students and Students in Clinical Laboratory Science. Dr. Field has been happily married for 33 years to her husband, Mike, and she has one daughter, Grace, who is a senior at Rice University majoring in voice and opera studies. So as part of the fall's first Science Study Break, when we are honored to be part of Natural Sciences Week, please join me in welcoming Dr. Leanne.
Okay, good afternoon, all these great snacks, and I'm so happy to be here. To set the stage, to go through some of these couple of house episodes. We're going to get back up to the front. And open it up. I'm going to give you about a 7 or 8 or 9 minute primer on emerging infectious diseases, and our body's defenses. So get ready to zoom through this. If you like it, you can come and take human infectious diseases with me. All right, this is the war within us. That is the microbes versus our host defenses. And I love this book by Cedric Mims. Oh, there you go, thank you. All right, let's go back. There it is, the war within us. All right, it's the microbe versus the human host. Sometimes we win, sometimes the microbe wins and kills the host, and always the battle between them is always part of the collateral damage to the body. Infectious diseases are the #1 cause of death in the world and #3 cause in the U.S. And here are listed some of the top infectious diseases worldwide. All right, what do the pathogens, the disease-causing microbes, bring to the table? Well, most of the time they are not pathogenic. There's only around 1,000 that can cause disease of the trillions of microbes. And not all pathogens are created equal. We have rather benign ones, like I'm suffering from right now, the common cold, or we have the deadly viruses that will kill you called Ebola and others. And here is a great quote from a Nobel laureate. Here we are, here are the bugs. They are looking for food, we are their meat. They reproduce so quickly, how do we compete? They have enormous potential for genetic change, and their tools for adaptation far outpace ours. But, with rare exceptions, our microbial adversaries have a shared interest in our survival. Almost any pathogen reaches a dead end when it kills the host. True severe pathogen-host interactions would eliminate both species. We are the contingent survivors of such encounters because of the shared interest. Joshua Lederberg. So, what do the pathogens want to do in us? To get in, find a safe niche, multiply, and reach the next host. How do they do this? There's a number of ways they're transmitted, and you can look for methods of transmission in-house. Respiratory spread, fecal-oral, poopy in the mouth, venereal spread, and then a number of infectious diseases transmitted from animal to man, and we call those zoonoses. Here is us in a nutshell, and most of the microbes get in on one of the internal surfaces of the body, because the skin is very, very tough to get into. Once they get in, they attach, they begin to multiply. Some, but not all, can invade deeper into the body, and they must exit the host, or they're not successful. They have to get in, multiply, get out to the next host, or they're eliminated. All right, that's the offense. Let's look at the defense. Our incredible, and it is our incredible immune system. Here we are in a sea of microbes surrounding us. The good news is not many of us will get sick. If we sprayed something in this room right now, we all breathed it in, only the tip of the iceberg would come down with disease. That's because our immune systems are so good. Our body, the castle, this is the analogy I use. We have layers of defense, including physical barriers and some incredible white blood cells, the phagocytes that are designed to eat and kill, and the incredible lymphocytes that make a tailor-made response and leave those memory cells behind to fight another day. 3 levels of defenses at the surface, right underneath the surface, and then the immune system defenses. So what about our body surfaces? They're well defended, whether it's the skin, the conjunctiva of the eye, the lungs, the gastrointestinal tract, or the genitourinary tract. These are all dynamic environments. They're designed to move the pathogens out of the body. Here's a look at those internal mucous membranes inside the body. If the microbes breach the defenses, you get the phagocytes, the eating and killing machines designed to kill them. This is a quote from George Bernard Shaw. There's generally only one scientific treatment for all diseases. That is to stimulate the phagocytes. This is not true for all diseases, but it is true for bacterial diseases, and House features a lot of bacterial diseases on their program. Here are just some beautiful pictures of the phagocytes reaching out to that tiny microbe on the bottom. Don't feel sorry for the microbe. They have defenses. Here's a macrophage, or neutrophil, sorry, eating a group of bacteria. Isn't that a beautiful picture? Such an incredible story. So bacteria are taken in, they're ingested, they're digested, and they're spit out the other side. That's it in a nutshell. So these phagocytes are circulating around in the blood, but that does no good if you cut your arm. You have to deliver them to the site of the infection via the process of inflammation. An incredible process where the blood vessels in the local area of the infection dilate and the phagocytes squeeze out and move to the site of the microbes. Again, this is all for bacterial diseases. Viruses, we have different defenses. These are the classic signs of inflammation known since the time of the Greeks: redness, swelling, heat, and pain. Here's some pictures of inflammation. Okay, this is a good sign. If you didn't have this, it would mean your defenses were not working. Here's what your throat looks like. And take a look at that white stuff, which is what? Pus. Pus, pus, pus. Pus means, we'll come back to that just a minute. Here's your ear infection, otitis media. This is pus. It's the well-known product of infection and inflammation, the stuff of boils and abscesses. It contains bacteria, both dead and alive, the phagocytes, and the fluid debris from the battlefield. We see it less common today, but it means when you see it, the phagocytes are in there working, and they are doing their best. In the old days, it was called laudable, praiseworthy pus. Now, also a feature of house is you will notice that many people that get bacterial infections, they do not get a fever. Well, I'm here to tell you that anytime there is a local inflammatory response, there will be a fever because the cytokines that are released travel to the brain and will set the temperature up to try to increase the inflammation and to limit the spread of the infection. If this doesn't work, to contain the pathogens, we bring in 7 to 10 days later, lagging behind in time, the lymphocytes that make that tailor-made response to leave the memory cells behind. Here's some just beautiful pictures of lymphocytes circulating around. They circulate around the body in the lymphatic and in the blood system, and each lymphocyte recognizes only one shape on the surface of a pathogen. And the battle with the lymphocyte occurs in the lymph nodes, shown here in green, defending the lungs. So when a lymphocyte meets the particular pathogen with a shape on the surface, it is cloned. It becomes activated, here showing lymphocyte number 2, begins to divide and differentiate into the cells that will take out the pathogen, and left behind will be long-lived memory cells. How did the lymphocytes take out the pathogen? Either coating it with antibody, and then those eat and kill phagocytes do it in, or they blow it up, a virus-infected cell. And memory cells are left behind, which is why we vaccinate people, so that you've seen it before, and the next time you see it, the infection will be fought very, very quickly. So those are our defenders. Surface defenses, the phagocytes, and the lymphocytes. Now when you think about immunology, and you'll see this in house, there are normal immune responses there. There are immunodeficiency diseases, and in that case, these are genetic inborn diseases, and what will happen to the person if they have an immunodeficiency disease? Will they be able to make this response? No, they will have a defect. Can you cause someone to be immunodeficient? Radiation, chemotherapy, cortisone, all of these things will suppress the immune response and tip the hand up for the microbes. Another possibility is hypersensitivity, an exaggerated response, that's your allergic response, and then the autoimmune response, this response against self. And we certainly don't want that. So when we think about genetic immunodeficiencies, we can have problems with the phagocytes. And you're going to see that in one of these house episodes. He talks about a particular phagocytic defect. I'm not going to tell you what it is. Or we can have defects in the lymphocytes, in the B cells that make antibody, the T cells that kill virus-infected cells, or the both, that is the boy in the bubble. You can't live without both of them, and that's called severe combined immunodeficiency or SCID disease. Okay, and we're going to start out, I think, our clips with a picture of the with a clip of the allergic responses. So I just wanted to kind of go through and let you know you're going to have antibody involved, and it's going to bind to these cells called mast cells, from the tip of your head to the bottom of your feet. The allergic moiety will cross-link these antibodies, and the mast cells will degranulate and release what? Histamine, okay? So think about what histamine does, and we will see the effects of it in just a minute. Okay, that's it. That's your little primer in immunology and infectious diseases.
And he'd been bit by a snake. A timber rattler.
Right.
Okay, so they gave him the antivenin, and it didn't go so well.
Okay. Anybody know what was happening to him? Anaphylaxis, right? The most severe form of an allergic response to the antivenom. Okay? And the interesting thing about that, I'm sure these are rare reactions, but any kind of type 1 hypersensitivity reaction, you have to be primed for it. So the first time you are exposed to the bee, if it stings you, it's free. The second time and subsequent times, you're going to have an allergic response. Can it happen that fast? I counted about 4 seconds there. More like 30 seconds to a minimum, to a minute would be a minimum there, but yes, that's why it's called immediate anaphylaxis. So that's a pretty accurate representation, and he has trouble breathing.
Snakebite guy is way more interesting. Gross, actually.
So, just so that we can, part of House that's the entertaining part for some of us is that there's always something gross every episode. So here's the grossness. Remember, there was a picture she showed you of redness and what have you. This isn't quite the same because...
well, it's beyond that.
Yeah. So
this is the microbes winning on that leg.
Everyone had enough of this image? Yeah, pretty much enough? Okay.
The patient responded to epinephrine and the allergic reaction was arrested.
Okay, so they talk about giving him the epinephrine after he had that reaction to the antivenin, and then you get the glorious Technicolor shot of the wound.
Right, so does anybody know how epinephrine helps an allergic response? That's exactly, so they're right, that's what they would do. What happens in the allergic response, anybody know, in systemic anaphylaxis? Okay, the blood vessels begin to open up in response to that histamine, and plasma pours into the tissues, and that causes the blood pressure to drop, the heart will stop, and there's also smooth muscle contraction of the bronchioles so that the person cannot breathe. So they must put in the epinephrine to reverse those effects, and then add the plasma back to expand the blood and restore the blood pressure. So all that's really pretty accurate. What we're going to do is show some things that are accurate and some things that are not so accurate. So he responded to the epinephrine and he was just fine, and that's the way it would happen. Yes?
So what happened to the leg, though?
What happened to the leg, we're going to continue on with the story of the leg. So this is a little, so he got supposedly bit by a snake. Okay.
I did neglect to tell you that. So they looked at him and they detected 2 puncture wounds, and they figured must be a snake bite, and they got with the park ranger type people to go out, and that's where the first clip you saw them holding up the timber rattler. So they gave him the antivenin, and that wasn't working out. So what they've done between that clip and this clip is given him some different antivenin, and they've stood by with cortisone so that if he had another reaction, they could help him. So they gave him that new stuff. He didn't, thankfully, have another reaction. And, however...
We gave the guy the antivenom. What if I'm allergic again?
So there's this.
Look here. If you have a reaction, Ready to do whatever's necessary to ensure your airways stay open and your heart keeps beating.
My wife's on the way in. Can't this wait?
I'm sorry. Can't.
Now notice how he does not appear to be in any distress. Okay? Even though his leg looked like what you saw it look like.
Okay, so that was him not having a reaction. Then the next thing that happens is, yeah, okay. So,
His condition's not improving.
however,
Double the dosage.
Already did. There's another antivenom that's effective.
Already tried it.
First stuff he was allergic to.
Gave it to him with high-dose steroids. Nothing's working.
What does it all mean?
Well,
so what does it all mean?
Okay. They're pretty much ignoring the leg, right? Nobody's talking about the leg. Does he look like he has a fever or is acutely ill? No. Okay. With that kind of wound, he would be in excruciating pain. Did he look like he was in pain? He's talking about, well, no, his wife's not here. Okay. So that is not really very realistic. So what does it mean? Let's see the next clip.
Okay.
You're dying.
This is a really
A
good
few hours. There's nothing we can do except deal with the pain.
Now, is that true?
I need to go home.
You're not going home.
Well, my dog. What will happen to my dog?
the neck looks clean. No, I know.
Wait. The guy's dying and all he cares about is his dog?
Any of you guys know the dog routing or in prawn sections? It's the basic truth of the human condition that everybody lies. The only variable is about what. The great thing about telling someone they're dying is that it tends to focus their priorities, find out what matters to them, what they're willing to die for. They're willing to lie for it. I mean, you must have a neighbor.
Neighbors don't like him.
So the Humane Society take me and find him a
No,
home.
they won't.
Hey, but maybe my hand. It wasn't a snake bite, was it?
I said I don't remember being bit.
Sure you did. Just not by a snake. I assume that Cusho bit one of your neighbors a while back. You tell me that he bit you, and I got to report it. Cusho's got a record. He gets the chair. Good news is, you might just live. Bad news is your dog's gonna die.
Virus is like to say this thing.
Okay, this is the diagnosis method.
I think I've got a better grip here. You go for a minute. Right. I'm on. Just do it. Let's let me let the guy die. Okay, just do it.
All right, they're collecting the saliva from the dog. Do you think that's a recognized method of diagnosis? How would they really diagnose that kind of leg wound? All right, speak up, Dina. Who's had human infectious diseases?
Culture the wound.
Culture the wound. They'd also be doing blood cultures because this serious kind of infection would not stay confined to the skin, but would most likely be invading and reaching the bloodstream, and that's what would really do the person in. Okay. So, what's our next clip? Is that the last one?
That's the last one.
Okay.
Dogs' mouths are pretty familiar. They have natural antibodies that fight off themselves. We don't. That's why dog bites can be so nasty. Lab tested your dog's saliva with a type of strep bacteria. It's commonly known as the flesh-eating disease. You need to operate immediately to remove the dangerous tissue. Leave maintenance of the life.
so they said the dog is not susceptible because he has natural antibodies, and they're talking about diagnosing it by culturing the dog's saliva. There would be many, many, many different things in that dog's saliva, so that is not an accurate method of diagnosis at all. Now, what else did they say, Roxanne, about it? Let's see. Oh, your leg might have to be amputated. That is definitely true. Okay, if a flesh-eating strep got into that leg, you could be dead in 48 hours. So again, it causes very, very excruciating pain. It's one of the most painful skin and soft tissue infections, and this man appears to be in no particular stress, so that's not quite realistic. Okay.
Okay. One of the best things about getting to work with Dr. Field on this is that I discovered a new game. Okay, it's the house game. It's actually not a drinking game. It is a using a library database game, which may not immediately thrill you, but the deal is there are two really great library databases that are perfect to call up on your laptop when you're watching House. And one of them is, because they're always going to throw out all these diseases and all these names, right? And you can look them up right away in Gale Virtual Reference Library. This database is a bunch of encyclopedias, basically, that used to be on the shelf in print, but now they're here. And so you can just look up flesh-eating disease and quickly find out just a little primer on flesh-eating disease. It describes it, talks about the symptoms, how it's diagnosed, what the prognosis is, just the basic stuff. You know, so this is really great. So you can play along with House, you know. So now you look at the symptoms, take it all down, and then go to a database and say, I think it's this, you know, and then you can, you know, or you can like check it, you know, when he's saying, oh, first we think it's this thing or something, go into Gale Virtual Reference Library and check up on it. So this is
notice under treatment, it says rapid aggressive medical treatment, specifically antibiotic therapy. And the couple of clips previous, you know, House said you're dying, there's nothing we can do for you. So, well, poor guy, you know, be under House's care. That's all I can say.
Okay, let's see. Now, we're ready to proceed to, right, stay tuned while we do a little technical back and forth thing, a little switching.
So how many people watch House regularly? Okay, good. So they're supposed to get a new resident on the 4th season. I'm kind of anxious to see how that goes, right? Foreman is going away, is that right? Oh, all 3 of them, they're starting over. Okay, well, it'll be interesting. 3 new people he can abuse, basically.
So how many had seen that episode? People remember that one? Okay. They had these other 3, remember the other 2 patients? One of them was a volleyball chick, right? That's what they called her too. They called her volleyball chick. And then the 3rd one was House. For those of you who don't watch the show, Dr. House walks with a limp, and it was explained to us in, oh good, it's here. It was explained to us how that came about.
In general, I think the first season of House is more accurate than each season that's gone along. It's a little more spectacular than the last. So.
This episode is from season 3. We're kind of jumping around. That one was season 1 that we just saw. It's called 3 Stories. This one's called WhackaMole, and it's from season 3. And I really like it because it has Patrick Fugit. I think it's great. So I was pretty happy about this. But here is the clip. Wait a minute. Let me pause this for a minute to tell you what's going on. Okay. In this one, this kid, Patrick Fugit, you have to do this when I say his name, Patrick Fugit, works at some like Chuck E. Cheese pizza birthday, and he's working one night when a bunch of kids come in for a birthday. Also, his younger brother and sister are there because their parents have died, and he is now their guardian and their sole support. So he's bringing out the big birthday cake when all of a sudden, and he's singing the little happy birthday song that they sing at this pizza parlor, when he starts, you know, the television shorthand that they use for things are getting hazy, you're getting sick, you know, the camera's doing like this and stuff. And then he runs over to the table, clutches his stomach, and just heaves all over the birthday cake, okay? And that was the gross part for that episode, but we're not showing it. But I can show you later if you want. So anyway, and then he clutches his chest and he falls to the floor, and the next thing you know, they're shocking him back, bringing him back, and they're saying we have a heartbeat, and they're taking him to Princeton Plainsboro Hospital, which is where how this works. And so they've been trying to figure out what's wrong with this 18-year-old kid that he was barfing and he had a heart attack and he's got all these problems. And they've been doing a variety of tests. House likes to not take anything seriously, and so he told each of his attending doctors that they could each do one test and they each had an hour. So they've all gone off and done their various tests, and they've come back. And now,
Chase, stop doing that. We're almost finished. It's got osteomyelitis. Ain't you wrong about foodborne toxins. And you can stop too. It's syphilis.
You sure?
Read it down.
He's also positive for Legionnaires.
Why, you two screwed up? No.
Not a chance.
Well, this kid is a lot sicker than we thought. Finish that test. It should be impossible to get 2 right answers to 1 question. It's okay to have 3. Apparently. He's positive for botulism too. So, we knock down 1 infection and 3 more pop up. I think this game is rigged.
Okay, what a mix of infections, okay? Osteomyelitis, which is what? Infection of the bone, okay, syphilis, Legionella, which is known for an infection you get if you have a fist fight and someone knocks you in the jaw. And then he also has botulism, okay? Anybody know what the symptoms of botulism are? This kid doesn't have them. You haven't seen the kid? Yeah.
Paralysis?
Right, so double vision first, and then ascending paralysis until it would hit the breathing apparatus, and you would have to go on a respirator, or that would be it, lights out, okay? So would they be seeing microorganisms under, first of all, it's amazing that they do all their own testing, right? These residents, they are experts in every lab test. They also run the MRI and all this complicated equipment, so that is not realistic. And this bewildering array of symptoms is highly improbable, okay?
He managed to clear all 3 infections out of his system, but now he's having seizures every few hours.
But they don't tell
He's
you
gotta be
that.
immunocompromised.
No. Blood count was normal and he was negative for HIV.
Well, he's not immunocompromised. Why is he acting like he's immunocompromised? What do the seizures tell us?
Nothing. There were no structural abnormalities on the CT, non-focal neuro exam, no electrolyte imbalance, nothing.
What do unexplained seizures and really sick 18-year-olds have in common?
You thinking Trump?
I'm thinking drugs. He's an admitted user. Drugs crash his immune system.
Tox screen was clean.
Clean tox screen means there's no drugs in his blood or urine. There could still be drugs trapped in his fat cells from the good old days.
If they're in his fat, why would they be affecting him now?
The keen observer would notice that he's had some digestive issues lately. His weight loss could burn out fat cells and release the drugs back into his system.
There's no way to know. It's impossible to test fat cells for drugs.
It's not impossible to make him lose more weight.
You want us to starve him so we can drive him into another seizure, maybe a heart attack, just so we can run another test?
That'd be cruel. Just sweat it out of him. I haven't touched the thing since the night my parents died.
Okay, so what do you think about this? Could you sweat out drugs in a sauna? Can you test for drugs in sweat? Well, actually, the answer is yes. And I contacted Dr. George Kudlow down at UT Health Science Center in San Antonio. They have a forensic toxicology program. So I emailed him, and he responded back that yes, indeed, you could have a number of drugs of abuse that could be stored in fat. They would first, however, be released into the bloodstream, and then they may also appear in sweat. So this sounds far out, but it's not that far off with reality. Okay, so we give them a check for that.
But they should have been able to detect it.
They should have been able, well, but they said that it was old drugs that had been stored in fat. So he wasn't presently taking drugs, so he might not have had them in his blood or urine. Okay?
It'll stay in your system a long time.
Okay, they're back to their
I
diagnostic.
was right. The abscess is from a fungal infection, Aspergillus, but we still have no idea why. Our kid's immune system has a factory defect. It's genetic.
It can't be genetic. He would have been getting infections since he was an infant.
Not if he grew up in a bubble.
Or if he grew up on Mars. No germs there either.
I don't mean a literal bubble. A sweet suburban bubble where mommies and daddies protect their children. They die, bubble bursts. Continuing emotional trauma triggers a genetic illness. The question is which one? Infections he's contracted narrow down the possibilities. Hep A indicates a problem with his B cells.
Conversions of gamma globulin in man.
Legionella, who's to a complement deficiency.
I have a patient. I need...
Not now.
I'll go.
You'll stay. Patient's dying.
So's mine.
In the next hour. What does the syphilis tell us? What does it tell us?
It could mean chronic granulomatous disease.
The Aspergillus is a T-cell issue. Common variable immunodeficiency. Genetic testing is going to take time. Given the rates pick up infections,
When we turn it into a race, little need to be playing games with us. Not you guys, the infections.
What infections?
The infections we're gonna give him.
The only way to cure me is to make me sicker.
Each of the 4 possible genetic conditions is most susceptible to different types of infection.
What's that?
This is a cocktail of Serratia, Meningococcus, Euphoria, and rhinovirus. Whichever germ gains the most ground plants the flag of its leader. Gives us our answer.
And how are you going to know which one gains the most ground?
Well, that's the fun part. See, the Meningococcus is king of the hill. You have to have a seizure. Serratia will shut down your lungs if it's capacious and a heart attack. It's the rhinovirus. You'll sneeze. Can't all be dramatic. We good?
I don't know.
Well, the alternative is we guess. And there's a 3 out of 4 chance that your little brother and sister will get to cry over another coffin. Study fractions in school? We good? Oh, and this test isn't exactly FDA approved, so let's just keep it our little secret, okay?
Okay, anybody want to comment about that? Reality. No, not at all. Did you notice again how this young man who is supposed to be ill with 3 or 4 different types of infections looks remarkably healthy, and he doesn't appear to have a fever or any other symptoms, except he's perplexed at House's plan to spray him with microorganisms. And he should be perplexed, right? And the idea that you would infect someone with different strains of bacteria, and he's throwing in the rhinovirus, and they would, whichever one won out, he would get those symptoms. Absurd is the only word I can use.
Okay. This turns out to be, at one point there was when House was with them and the whiteboard and the things, they were throwing out the names of different diseases. I don't know if you remember that, but do you have any idea what it turns out to be that he had? We got any guesses on what he winds up with? If only. He winds up with something called chronic granulomatous disease, and I'm not going to go back to the other laptop to show you, but remember Gale Virtual Reference Library and how we looked up flesh-eating bacteria? Well, you can look up CGD, chronic granulomatous disease, in there as well, and you'll get to see a bunch of things about it,
including that it would present in young childhood, infants and young children. So it's a genetic defect in the phagocytic cells. They have trouble in that inflammatory process squeezing out of the blood vessels and making it to the actual tissue where the infection is, and then they're able to engulf bacteria, but they're missing a key enzyme, so they cannot kill them. But the idea that this 18-year-old could have had this disease for 18 years because he grew up in a suburban bubble, he would not have displayed the symptoms of that. Again, it's absolutely absurd.
So now, and I know we're just whipping right through these, but there's so much house goodness to talk about. So now we're in season 2, and this is the dramatic 2-parter. And so I'm guessing maybe part 1 was like before that Christmas hiatus when all the shows go off and you just get the old stuff. Yeah. Okay, in this one called Euphoria, this gentleman here on the bed, the patient, is a police officer, and it opens with him chasing someone down an alley. And then the person seems to disappear. Well, they've jumped into a big trash bin. So he gets that person to jump out, and he's holding a gun on them, and but he's laughing like a loon. Okay, the cop, not the suspect. And the suspect's very confused by this behavior, and the cop isn't really on his game. So eventually, the suspect's able to pull out a gun and shoot him. Well, it bounces somehow off of some metal. He's got Kevlar on, but there's metal here too, and the bullet breaks. And it comes up and it hits him, and he's lying there, and the suspect runs away. And this guy's lying there in the street, bleeding that movie blood, and laughing like crazy. So they have brought him into the hospital because this is not the normal reaction, among other things. And he's been shot. So they want to know what might have caused this to happen to him, and they're asking him things about his environment.
No, I keep a pretty clean home.
They just asked him if he was exposed to anything insanitary. The foreman has gone to look at his house. These people are always like doing home invasions to look at the patient's houses. This is the gross stuff for this episode.
If you start having cold bleeding, you can press this button and the chamber will decompress.
Like this?
So they put him in a hyperbaric oxygen chamber in order to help him with carbon monoxide poisoning.
How bad does it hurt?
Not at all. That's wild though, huh?
Your brain's not getting enough oxygen, you're losing motor function. We should stop this right away.
Should I be scared?
No, you probably have a carbon monoxide leak in your place. We have a guy there checking things out.
So this guy's doing a little home gardening.
Okay. So, like when in the old Encyclopedia Brown Mysteries, it's all here. It's all there. Everything that you need to know.
You never know.
House goes to the police station while the foreman is examining the guy's home.
Who's your partner, Sid? Place is a cesspool, but I don't think I need to test for anything. Nope. Waste of time. You know about the marijuana? I've heard rumors since junior high. The cops acting on it for years. He's got Legionnaires disease. It's a good thing Joe got shot. The whole precinct would have got wiped out. Anarchy on it. It takes 48 hours to test for Legionnaires and 2 seconds to recognize that the symptoms fit while staring at the rancid, unchanged water in AC. Marijuana explains the high carboxy, the cloudy lungs, and the happiness.
Pot doesn't explain the fact that he's gotten worse since he was admitted. Why don't we agree to disagree? Actually, why don't we agree that you'll disagree with me while treating him for Legionnaires? Sounds pithy, but...
Okay, so once again, Gale Virtual Reference Library. It's a pain to switch back and forth between the laptops, but after I finished talking to you, I ran to that database and I looked up Legionnaire's disease. And
anybody know anything about Legionnaire's disease? Yes, sir.
It comes from stagnant pools of water.
It comes, the bacteria, right? It's an environmental reservoir, and it's usually associated with large air conditioning units. I haven't ever seen it associated with a window unit like you saw there. It's usually part of the big condensing pools, as you said. The organisms are living in the water. The original outbreak was among American Legionnaire attendees during 1976 in Philadelphia, hence the name Legionnaire's disease. What kind of disease is it? He's told us the source. What kind of infectious disease? Bacterial infection, yes, it is a bacterium. Legionella pneumophila, good. Okay, what kind of disease what would the symptoms be? You saw one of the policemen over there was coughing, right? So it's it's a cause of community-acquired pneumonia. Okay. Notice House didn't do anything about the other cop there who was showing symptoms, and you'll see that the person that he is taking care of doesn't appear to be coughing so far, and so they've jumped to the conclusion that he has Legionnaire's disease. Is it contagious? Can you spread it person to person? No, you can't. You have to have an environmental reservoir. Another source of Legionnaire's disease has been the supermarket produce section where they spray the mist on the vegetables, and people have breathed that type of mist containing the organism and come down with this form of pneumonia. Okay? So he's right, House is right, it could be that, except not from a window air conditioner.
So between this part right here and the next part that we're going to see, this cute Dr. Foreman gets sick. He starts laughing at everything, and so they wind up putting him in an isolation place, and they put Joe, the cop, in an isolation room as well. And suddenly they seem like really, really motivated to solve this. It's kind of not a good, statement about doctors, but they get all of a sudden real motivated. And Dr. Cameron goes back to the house to gather more samples, back to Joe's apartment to gather more samples to see if maybe they missed something, because now they're going to rerun these tests.
I feel a lot better.
What to do to make you hate it?
And House catches her at it. He told her not to go.
Give me the bag.
We're going to talk about a lot of diseases here, so be thinking about which are your favorites that you might want to bet on.
Mildew, dish towel.
To retest for staff.
Was that mouse droppings?
Hamster droppings could carry toxicoma, explain the blindness.
How bad I recognize this other fraud.
Could be me with trichinella, would explain the high fever.
What's with rye bread?
Mold could be responsible for airgun poisoning, which could explain the contractures.
3 loaves.
So?
You're going back in there. Guy who lives on takeout pizza does not buy 3 loaves of rye. He's looking too far into the future.
Glenn cares about something a lot more than his diet. You on the roof yet?
Yeah, I'm here. I don't see any birds.
Whistle or something.
Do that come hither thing.
Their behavior pattern.
Joe's been feeding them. Now look down. You see a river of pigeon turd?
No. There's barely any.
It's not weird, it's cheap.
Joe's the guy who looks for the easy way.
Probably been stealing cable from his neighbors.
Why not steal fertilizer from rats with wings? You see a shovel or a dustpan?
Found a scrape that Brooks used. Sitting in a bucket.
Bucket full of pigeon crap. Perfect home for Cryptococcus neoformans.
Yuck.
Fungus enters the brain through the sphenoidal sinus, where it dances its triple threat of happiness, blindness, and intractable pain. Well, let's hope this experience teaches our cop a lesson. Don't cut corners when you're growing your pot. See you back home.
Okay, anybody know anything about cryptococcosis, Cryptococcus neoformans? Okay, this is a yeast, very, very serious, disseminated fungal infection. Now, I'm not sure about his symptoms. Did you want to look Cryptococcus up in the reference? So they're trying to account for blindness, euphoria, laughing. All of these would indicate something's in the brain. None of those symptoms fit with Legionnaires' disease, so that's kind of a little incongruous. So the thing to do would be to go and look up the symptoms of Cryptococcus neoformans, the cause of cryptococcosis.
And we had an uncommanded shutdown, so...
Oh, we're having a technical problem.
We're having a technical,
okay.
yes. You know, it was
So-
too good to last. So. But it, once again, was something that I was able to find in the Gale Virtual Reference Library. And I looked up Cryptococcus neoformans and found an article on cryptococcosis, okay, that had the same lovely format of definition, and then the symptoms and the prognosis and the treatment and all of that, as well as some references to other things to look at.
And the diagnosis for this, which they never get to, would be a lumbar puncture in order to recover it from the spinal fluid. Okay, so again, they're not quite right on with their diagnosis. They are right in that it has an environmental reservoir and it is associated with pigeons and bird droppings.
And what's funny about that is, like, every week, I mean, we lay bets on it. You know, house comes on and people come in and they've got like cuts and gaping wounds, and the staff is all like, let's do an LP, you know, a lumbar puncture. That's their answer to everything. And then this one time,
when it would be appropriate,
when it would have been the thing to do, you know.
They're not doing it.
Yeah, so go figure.
So we go to another clip?
We are. We're going to move into part 2 of Euphoria, and what happens here is that the guy Joe, the cop, he's really, really sick. He's dead, actually. He dies in horrible pain, intractable pain, and Foreman is in the isolation room with him, observing this and knowing that his disease will also progress in this way, and that he will face this pain as well. And so.
Which that kind of pain is not associated with Legionnaires' disease, nor is it associated with cryptococcus. So these are kind of some unusual sets of symptoms that I couldn't match up with anything I know about.
Foreman was perfectly healthy before he got this infection. The cop wasn't. Again, Legionnaires disease. The cop was trying to brain the cure of Legionella. Legionella slowed down the disease. Why would that happen? No idea. Just know that it did.
You want to infect a vomit?
Vets can't help me with the same hand. Get it? Just take the pain away from me under. No wonder I can't monitor the pain. I can't monitor the pain. I was working. I'm not just sitting here giving me smokers. It's going to be much more dramatic. Keep your slippers on. Don't you touch your blood. Everybody else stopped. Exactly like the cop and exactly like Foreman. And what if the patient was then exposed to a second infection, like Legionella? The body would recognize that infection, increase the white cell cells, troops, and start fighting the initial infection, get caught in the crossfire. So the question becomes, what type of bacterial infection affects humans but not rats? And the human body would be unlikely to recognize. The answer is listeria.
He said listeria. I know that cut off a little soon, but the answer is listeria, is what House said.
Okay, so do you remember what I told you about the lymphocyte response and the immune system response? Only one particular shape on a lymphocyte would recognize the pathogen, and the cells would begin to multiply and make your response to produce antibodies. So House is claiming here that the first infection you'd be making an antibody response, and the second infection would get caught in the crossfire by the antibody response. And that's not true, because the lymphocytes are, it's like making a tailor-made suit of clothes. You're only going to make a response to that one pathogen, and it will not cross-protect you against a totally unrelated pathogen.
So finally, a little more detective work.
Legionella attacked the parasite. That's why the disease slowed down.
Is it treatable?
He started him on an antiparasitic, and the amoebas will clear out of his system.
This was a race between House running back to Joe's apartment to look for what could be possibly causing this, and they were standing by, meanwhile, at the hospital. Dr. Cameron was Dr. Foreman's medical proxy, and they were standing by because they were going to find out by doing this brain biopsy. So House was racing to try to get this before they had to cut open Foreman's head, but they did it anyway.
Okay, so the diagnostic test for primary amoebic meningoencephalitis would be cerebrospinal fluid, lumbar puncture, and you would see the organisms multiplying in the spinal fluid. The whole premise of this show was they had to do a brain biopsy in order to diagnose it. And you'll also notice that, what did she say they could do for the infection? So it's a protozoan infection. What did she say? Antiparasitic drug. This infection is 100% fatal. Okay? And you're dealing, they're contrasting a lung infection with Legionella and Naegleria, which would be in the cerebrospinal fluid and up in the brain, and claiming that there's a connection there between them. All right, yes, you would breathe in the Legionella if the guy is, potentially growing his marijuana, and you saw that moisty, the way he was kind of irrigating, and you could get that way. You could get Legionella that way. You might breathe in the Naegleria if they were in the contaminated water, but it would go to the lungs, right? It would not go up to the brain. The way that this infection of primary amoebic meningoencephalitis is always contracted is by what? Through the nose, and it's diving into stagnant water. So you have to forcefully force the water up the nose, and it crosses the cribriform plate and goes immediately into the central nervous system. This is extremely rare. We have had, actually, 2 cases in Austin in the last few months. Here is the most recent one. This one is dated September 8th. So back in the summer, we had a young man at a summer camp who was diving in Lake LBJ. He contracted it, was taken to Dell Children's Hospital and died. This was a man at the same lake who also contracted it by diving, and he also died. It's 100% fatal. So the idea that you could somehow give him an antiparasitic drug and he'd be just fine, does not line up with reality. Okay? Usually it's associated with diving into stagnant ponds with mud on the bottom. They are hypothesizing that perhaps all the rain we had this summer maybe stirred up the mud in these lakes. Normally the lakes are so, there's so much movement of water that you would not expect Naegleria from swimming in the lake. But this kind of makes you think. Here it is right in our own backyard. So. Okay.
What we have here is a database called StatRef, and I just went from the library's main page under research tools. There's databases and indexes to articles, and it's just under the S's. And it's a collection of medical texts, and so I just typed in primary amoebic stuff and searched it, and there were like 7 or 8 entries from different textbooks, medical textbooks that came up, and I picked this one. And you can see how it's talking about exactly what she said, how this is contracted, not necessarily by standing next to some water that's doing this business, but by diving so that the water is forced up into the nose. And so you can use this as well to check on Dr. House. When they talk about how something happens, maybe a person could contract that, although as you said, he'd die. But
he would have been dead way before 2 episodes.
Yeah.
Yeah, it's like 70 hours. It's very, very fast. That young man that contracted it was dead in just a couple of days. Yeah. Very fast.
But here you can check on things like the mode of transmission, the methods of control, so that if part of what they're saying is right, a person could catch disease, could get disease A, but could they get it this way? So here's another source for checking up on House. So next Tuesday night, the show starts season 4. I think it's 8 o'clock. 8 o'clock. So fire up your laptops, go to the library main page, and use our databases so that and then you can write those letters that are fun to write to the network saying, well, actually, I checked and Okay. Any questions or comments?
Any other questions? Yes.
While this instance isn't realistic, does this sort of thing ever occur where 2 infections battle each other within the body?
Yes, very unusual combinations, especially when one infection has a tropism for the central nervous system, the other one is in the lungs, and they wouldn't even be close to each other in the body. And the antibodies and the immune response really can't fight well up in the brain because it's not well defended.
Well, I'm saying like there were 2 infections in like the same place. Does it ever occur where like 2 infections in the body do actually fight each other like they were suggested?
All right. The question is, would 2 infections in the body be fighting against each other? No. The immune system would be fighting both of them at the same time. So Roxanne showed me that if you want to buy the DVDs, which is what we did, and watch all of the House episodes, they're all summarized on Wikipedia, which I thought was pretty amazing. And so we just went down and picked out the episodes that had to do with infectious diseases. And so it's really been a lot of fun. And so I hope this perks your interest in infectious disease and the topic of microbiology. Consider me a living reference. If you have any other questions in the future, just shoot me an email and I'll be happy to answer them. Okay, thank you.
That's pretty much what we have, but before you go, please fill out the, please applaud. Yes, yes, please work very hard. She worked so hard on this program and she educated you so much. So
I laid on the couch and watched about 13,000.
Also, on your chair was a pencil and a form, and if you would just let us know what you think about the program, let us know what programs you would like us to do in future, and give me the secret to Lost, okay? Fill that out and just leave it in your chair with your pencil, and take more snacks on your way out.